All right, today's lesson is on section 1.3, line segments. As you recall from section 1, we learned the undefined terms of geometry. And so my question before we get started is, do you remember what those were? Sometimes they were called the building blocks of geometry. If you remember, they were point, line, and plane. Phenomenal job. All right, today's line segment. Right? Line segment is a part of a line between two endpoints. And so the book's definition is right there. But I'm going to go ahead and type my definition in. Again, a line segment is the part of the line between two points that are called endpoints. And so that is the definition I go with. They say a line segment is a measurable part of a line that consists of 2 points called endpoints. Very similar. All right. And so if you look at the picture here that they give us, they're showing a whole line. It's got arrows at the end. Whereas if I just say I want to start at A and start at B, that would just be a line segment. So this is a picture that could be either or, a line or a line segment. And so it really matters that you know what we're talking about. And I can't seem to turn the... that you know what we're talking about. And I can't seem to turn the... Technical problem there. Got it figured out and sorted. Let's keep going. All right. Let's keep going. All right. Do you mean the line or the segment? And so it's very important when we're talking about this, we note the notation. The notation here of a segment versus the notation on the right side of a line. So they both could be either letters. Order doesn't matter the letters. AB or BA. AB or BA. And so that little line above it, if it doesn't have arrows, then I would read that as segment AB or segment BA. This I would read as line AB or line BA. So what do you want to talk about in the picture? If you want to talk about the whole thing, then you would use the notation of line. If you only want to talk about from A to B, then you would use notation for segment. Right? If I have a point here and a point here, and I want to connect those points using a straight line, I'll do my best to draw a straight line. That's pretty good for me. And I call that line PH. Then it wouldn't matter if I name it PH or HP, but if I'm talking about segment PH, I need to have that little line above it. And so that's how I denote or make the notation for a segment. And next we have something called the segment addition postulate. And so if I look at this picture in the blue, the big thick blue line in this picture, how many segments do you see? I see 3 segments. There's segment AC, segment CB, and then the whole thing AB. And so it's probably important that you write down in your notes the segment addition postulate. It'll come up again later on when we're past this unit 2. Anytime we're adding segments together, we call it segment addition or the segment addition postulate. So you want to make sure you make a note of that. Right? Again, 2 smaller segments added together make the larger segment, or I sometimes will say part plus part equals the whole. Seems pretty self-explanatory, but later on when we come back to this, we've learned so much that we forget the self-explanatory easy stuff from the beginning of the year. So I would make a note of it. And so here's the first example. We have this whole segment XZ, and it wants us to find the measure of XZ. It's important on these problems to know what you're trying to find. So this one wants you to find the whole segment XZ. It tells us XY is 11.3 and YZ is 3.8. And so I'm going to plug in 11.3. That was terrible. Let me rewrite that. 11.3, 3.8, and those added together make xz. And so I do the math there. I get 15.1 equals xz. You try it now. Take a second, pause the video if need be, go back and look at the last one if you need to, but give this a try. Can you find segment SU? That's the whole segment, by the way, SU. Right. Hopefully you got 13.2. All right, the first part 7.4 plus the second part 5.8 equals the whole thing. SU equals 13.2. Now, why down here did I not write segment SU? If I just write the letters, that stands for length or distance. And so when they say find SU here, they're not saying find the segment, you just point to it. When they say it find with no segment above it, they're saying find the length of SU. Right? Example 2. Example 2, you have problems like this in your homework, but they're nowhere near as difficult. Right? Example 2 has these weird fractions and stuff, but I didn't want to back away with it just because they had fractions. But let's talk about the basics here. I want to find QR. So QR is right over here. I want to find that part of the segment. I know the first part is 6 5/8. I know the whole thing is 13 3/4. And so through segment addition, I can do the first part plus the second part equals the whole thing. Now, I'm going to plug in QR instead of question mark. And then I want to change 3/4. If I times the bottom by 2, I get 8 down there. And then 8 matches 8 on the bottom. And I times the top by 2, I get 6/8. So now I can minus 6 5/8 from both sides. All right. 13 minus 6 is just 7, so QR equals 7. 6/8 minus 5/8 is just 1/8. And so QR is 7 1/8. Example 3, you're going to have problems like this as well, especially on assessments, maybe even like an SAT test. They like to make this because it's wordy and it sounds harder than it is. So let's break it down. Find the value of x and BC if B is between A and C. Right now, that's confusing. So let's take a second and draw it out. That's my problem-solving tip. So I know I have B is between A and C. Right? And so B is somewhere inside here. I don't like to draw it directly in the middle because it doesn't say it's directly in the middle, so I want to be careful not to mess with my own brain. And then it says AC. It says the whole thing. A to C, the whole thing is 4x minus 12. Right? It says that right here. Next, it says AB is x, and it says BC is 2x plus 3. And so AB, I'm going to put an x in, and then for BC, I'm going to put 2x plus 3 in. And so I made myself a little picture to help myself out, and then I'm just going to do part plus part equals the whole. So x plus 2x plus 3 equals the whole thing, 4x minus 12. Right? And so that's where I'm going to start off doing my math, right there. And so I'm going to rewrite that over here, x plus 2x plus 3 equals 4x minus 12. All right, that's 3x plus 3 equals 4x minus 12. I want to subtract 3x from both sides. I would write minus 3x down here and down here if I had more room. But I'm just going to tell you I'm doing that. Minus 3x from both sides. I get 3 equals 4x minus 3x would be 1x minus 12. Now I'm going to add the 12 to both sides. I'd write plus 12 here and plus 12 here. I get x equals 15. So now that I know what x equals, I also, because it said two things, find x, which I did, x is 15, and find BC. So now I need to find BC. BC equaled, it said over here, 2x plus 3. So 2 times 15, that's what x is, plus 3 equals 2 times 15 is 30, plus 3 is 33. So I have my answer for x, right? Let's highlight that. My answer for x is here, and then BC is over here, 33. You give it a try. Take your second, draw it out. Give it a try here. Notice it says y is between x and z, so maybe draw that first. Then mark it all up. Pause the video now, give it a try. Go back to the last problem if you need to. All right, let's see what you came up with. I'm going to just draw it out real quick for myself even here. So I have x and z and y somewhere in there. And then the one part it said was 19. And this part it said was 2x plus 5. And then it said the whole thing was 6x plus 12. And so for me, I would do 19 plus 2x plus 5 equals 6x plus 12. 19 plus 5 makes this side. Remember, do all the math you can on one side before you try to combine sides. All right, so 19 plus 5 is 24. All right. Now I'm going to subtract 2x from both sides. I'm going to then minus 12 from both sides. Then divide by 4, and I kind of ran out of space, so I'm going to write over here that x equals 3. And then you had to plug it back in to find xz. And I don't have room, so when you plug it back in, 6 times 3 is 18, plus 12 is 30. Hopefully you were able to do that successfully as well. Last kind of vocabulary word you need to get today is the word congruent down. So make sure you get this word congruent into your notes. What does congruent mean? Just this part right here. Same size and shape. Right? Same size and shape. So if the two segments have the same size and shape, I mean they're segments, they have the same shape. So they have the same size, and then we call them congruent. Notice these tick marks, these little tick marks here. That's how you can tell that something's congruent by looking at the picture, so you don't have to necessarily see it. The tick marks there. Might need to make a note of that too. That'll happen a lot. Those little marks will try to help you out and say they're the same. And then this symbol like an equal sign with a little squiggle on it, we're going to use that symbol a lot in geometry class. That symbol means congruent. And so for this, I would say segment AB is congruent to segment CD. All right. And so you're going to end up using that by the end of the year. You're going to use that little symbol for congruent a lot. And so this is, again, we have problems like this in the homework, and this is, again, harder than I think the ones are in the homework. But I didn't want to back down from it. I think it's good to work through. And so notice here, it gives me all of this stuff, but it gives me a picture. It gives me everything I need. Because I see these little tick marks here, I know those two things are equal. So I can go right into solving. 6x plus 20 equals 2 times x plus 6, which tells me to distribute over there because it's a 2 on the outside of parentheses. So 2x, 2 times x is 2x, 2 times 6 is 12. Minus 2x from both sides. Minus 20 from both sides. 12 minus 20 is negative 8. Divide by 4 on both sides, I get x equals negative 2. All right. Having a negative is very strange in geometry for a final answer. All right. It's why I know one of the many reasons I don't really care for this particular problem. All right. But it's good practice. It could happen. It's not, the math's not wrong. All right. Just, that, the distance can't be negative. It exists in real life. So our answers aren't negative very often. But it's good practice for algebra here and getting the practice of solving a problem. All right. Feel free to rewatch this video as you need to. All right. We're going to try to complete the assignment here on page 23, 24. I jumped around to try to pick problems I thought were best and easiest for you. All right. If you're having issues with it or you need a reduced assignment for some reason, feel free to send me an email or just make a note of that when you turn it in. 1 through 5, 10 through 12, 24, 28 through 30.